Okay, today we are doing scientific notation. Scientific notation. I can compare and order numbers using scientific notation. I can write numbers in scientific and standard notation. A number in scientific notation is written as the product of two factors in the form a times 10 to the nth, where n is an integer and a is between 1 and 10. All right, so first, uh, an integer. An integer is not a decimal or fraction. That's important to remember. So we have um, so this, yeah, in exponent is not a fraction. Okay, and you can see a is between 1 and 10. So a, see 3.4, 3.4 is between 1 and 10. So you have, let's say, 1, and this is 10. 3.4 is about right here. So it's between 3.4 is between 1 and 10. 5.43. Got 1, then 10. 5.43 is about right in the middle. 5.43. Okay. And 2.1 times 10 to the negative 10th. 2.1, and I think you know. You have 1, 10, 2.1, about right there. So, are these numbers written in scientific notation? Okay, so this says 0.46 times 10 to the fourth. 0.46. So we'll do 1 to 10. 0.46 is not between 1 and 10. It's below 1. 0.46. So it's not between 1 and 10. Are these numbers written in scientific notation? No. Example 1, no. 3.25 times 10 to the negative 2. Okay, so we have 1 and 10. 3.25? Yes, it is between 1 and 10. So we'll say yes. And 13.2 times 10 to the 8th. 13.2, so we'll do 1 and 10. 13.2, well, that's above 10. 13.2, so it's not between 1 and 10. No, no. Okay. You try and explain your reason. Okay, so uh, 3.42 times 10 to the negative 7. Okay, so we'll try. What we'll do is, So first off, we can do it because 3.42, 1, 10, 3.42, yep. So 3.42 is between 1 and 10. So yes. Okay, let's look at this one. 52 times 10 to the fourth. We have 1 and 10. Okay, 52. 52 is not here. 52 is way over here. So, no, no, we cannot, this is not in scientific notation. And 0.04 times 10 to the negative fifth. Okay, we have 1 and 10. 0.04. It's not between 1 and 10. 0.04. Ooh, it's way down here. So, no, can't do this one. Okay, but we can do this one, 3.42. So, let's figure out how we can do this problem. Okay, we'll go to the next page. So, writing a number in scientific notation. So, we'll do, okay, well, we'll see the explanation right here. So, an elephant's mass is 8.8 times 10 to the fourth. It's between 1 and 10, so it's good. And if it's a positive exponent, it indicates a number greater than 10. Move the decimal point to the right. So 8.8 times 10 to the fourth. So we have 8.8, and then we need to move it 4 places to the right. So we go 1, do, so we got 1, 2, 3, 4. So we have the decimal right there. So let's see. We have, I'll write that out again. So that's 8, 8, and 3 zeros. 1, 2, 3. And then with 3 zeros, we do a comma. So that's 88,000. Okay. So 8.8 times 10 to the fourth is 88,000. Yeah. We can check it too. We can go 1, 2, 3, 4. Yep, that's where it started. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And yeah. And ants' mass is 7.3 times 10 to the negative fifth. So we got 7.3 times 10 to the negative fifth. Negative exponent indicates a number between 0 and 1. Okay, move the decimal point to the left. Okay, so we're moving it this way now, to the left, because it's a negative exponent right here. So we'll write this 7.3 out here. 7.3. Actually, I'm going to move it about right here. 7.3. Okay. And then 5 places to the left. So we got 1. That's 1. Okay. 1, 2, 3. Sorry. Okay. 4, 5. Okay. So that's 1, 2, 3, 4. Yep. I made a mistake. Okay, we all make mistakes. Okay. So we have 7.3. I'm gonna do 4 zeros. 1, 2, 3, 4. Okay, so that's 1, 2, 3, 4, 5. There we go. So the decimal now is right there. So this is point, we have 4 zeros. 1, 2, 3, 4, and then 7, 3. Okay, so we move the decimal to the left because it's negative. So 1, 2, 3, 4, 5. And we can check it by going back again by 5. 1, 2, 3, 4, 5. And that's where it was originally. Okay. So let's take a look at this example 1. So we need to put this in 234 million in scientific notation. Okay, so we know that it needs to be between 1 and 10. So we'll do 2.34 because 2.34 can go into between 1 and 10. If it was, let's say, 23.4, that cannot go between 1 and 10. So it cannot be 23.4. Okay. So it's 2.34. And then let's see. So we always do times, right? Times 10 to the something. So times 10. Okay. And let's see. So we want to make this smaller. So we're going to make this 2.34 into this bigger number. So to make this 2.34 bigger, we have to have a positive exponent to make this big. So let's see, we have 2.34. So how many zeros do we need to add? Okay, so we're going to have to add this. So that's 2. So 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th. Okay, so that's scientific notation. So 2.34 times 10 to the 8th. That equals, I'll do 2.34. That equals, I'll do 2, 3, 4. That's 2. 1, 2. And then we add 6 zeros. So we have 3 digits here. So then 1, 2, 3. And then 3 more digits. Because 1, 2, 3. So that's 1, 2. And then 3 digits. So 2 plus. So we have 6, 1, 3, plus 3, 6, 7, 8. And it's 10 to the 8th. Okay. So we'll do example 2. So we need to, again, make it between 1 and 10. So that would be 6.3 times 10. It's always times 10. Times 10. Okay. Now, we want to make this smaller. We want to make the 6.3 smaller because this is smaller. So it should be a negative exponent. So let's see. And we know, you see, we'll do, yeah. So 1, 2, 3, 4, 5. Okay, 5. Yeah, and then we can do it again. So that's 1, and then we'll add 4 zeros. 1, sorry, and then 4 zeros. So we have, because we're making it smaller. So that would be 1 and 4 zeros. 1, 2, 3, 4. So let's see. That's 1, 2, 3, 4, 5. Boom. Okay. So I'll do this one. Again, between 1 and 10. So that is 2.67 times 10. Okay. And we want to make it big because this is bigger. So it will be positive. And then 2.67. So what we'll need to do is we'll have 1, 2, 3, 4, 5. 5. See, because then we do 1, 2. That equals 1, 2. That's 2. 267. And then 3 zeros. That's 5. 3 zeros. That is 5. And we have 5 right here. All right. Let's see. This would be 3.25. 3.25. 0.25 times 10. We want to make it smaller because this is smaller. So it's a negative. And so we'll have to do let's see. 1, 2, 3, 4, 5. 5. Okay. And then we'll do it over again. So -5, so that means this is gonna make this smaller. So we'll do 1 and then 4 zeros to make it 5. So we'll do 1, 2, 3, 4, and 3, 2, 5. Yep, and that's the same as this. 1, 2, 3, 4, 3, 2, 5. Okay. I think that is good for now, and that's good for today, and we will work on it some more tomorrow. So that's the first part of scientific notation.